In order for us to fully understand why integration works, we need to understand the fundamental theorem of calculus 1 and 2. In the previous video, we've already seen this. In this video, we are going to look at this. So let's look at the textbook's explanation. So the textbook's explanation is saying that whenever f prime of x, whenever the gradient function is the same as another gradient function, meaning that f prime of x is exactly the same as g prime of x. So whenever they're exactly the same in between a and b, then the textbook is saying that the original function itself, the two original functions itself, must differ by a constant. Now you won't understand this bit, so let me just reinterpret the whole thing. So let's just imagine we've got this situation here where the two gradient functions are exactly the same. They're exactly the same. What this thing is saying is that how do we know that there doesn't exist a function out there where when you differentiate it, it gives you g prime of x? How do we know that there isn't another function out there that when you differentiate it, it also gives you the same gradient function? What this book is, what the book is saying is that if you have two gradient functions that are exactly the same, then the original function g of x and f of x must be exactly the same but differ by a constant. So for example, let's say it looks like this. This is g of x. Whatever f of x, it must be exactly the same but differ by a constant. So you plus, I don't know, 3 or something. Or it could look like this. But it can never be something like this. It can f of x can never be a different function from g of x. So that's what it's saying here. So in short, suppose you have two gradient functions that are exactly the same. How do we know that there doesn't exist two functions that are totally different and they happen to when you differentiate them, they happen to be exactly the same? How do we know that for sure? The book is saying this book is saying that it will never be the case. It will never be the case. They must be exactly the same but differ by a constant. So for example, something like this. They must be exactly the same. So for example, let's look at let's just imagine it looks something like this. Then there must be exactly, so this must be g of x, this must be f of x. They must be exactly the same but differ by a constant. How do we know that this will always be true? And the trick to understanding this, the trick to understanding this is to use what we learned in the previous video, where we need to make use of this in order to understand why that's the case. So in the previous video, we said that if f prime is always 0, then the original function itself must be a constant. So f of x must be a constant. We've already seen this. I've already explained this. So I'm assuming you understand this. So hang on. So if you've been given this situation where you're told that g prime of x is exactly the same as f prime of x, then when you get f prime, take away g prime, then it must be equal to 0. So hang on. So when given this situation, let's create a new function. Let's just label it. Let's just call it f prime h prime of x. Let's just define this this function as being f prime take away g prime. So this is nothing more than a name, nothing more than a label. It's just a name given to a new created function, which we are going to define it as f prime take away g prime. But because we know that these two are exactly the same, this thing here must always be equal to 0. This thing here this block here is always equal to 0, because if the two gradient functions are exactly the same, then the difference between them must always be 0. Because look, let's just imagine this is 7. What's 7? Hang on. What's 7 take away 7? It would be 0. Let's look at this bit here. Let's just imagine this is 6. What's 6 take away 6, it would be 0. So here we've got this h prime is always equal to 0. So from our previous video, then that means the original h of x, the original h of x must be a constant, So when you integrate this, hang on, so when you look at h itself, it would be a constant. So for example, it could be a 4, it could be a 5, it could be a 6, it would be a constant. So when you integrate this, it would be a constant. So when you integrate this, it would be f, I don't care what the function is, g prime, when I don't care what the function is, when I integrate it, it would be g of x. So now from here you can add this block to both sides, so that will then take you to here. Switch these two around, so I'm just, well, switch those around, it will then give you this. So what that means is, going back to that's why f, whenever you have two derivatives that are exactly the same, then the original function itself must be exactly the same but only differ by a constant. So for example, if you look at if you're told that f prime and g prime are exactly the same, then the original function, let's just imagine the original function is this, then g of x must also be of the same shape but differ by a constant. Okay, so this was the textbook's explanation. So hang on. So whenever the two derivatives are exactly the same, then the original function, the two original functions must be exactly the same, only differs by a constant. Okay.